Now that we've looked at phantoms for the two-sample t, I want to take a closer look at the hypotheses and the conclusion statement. So let's start with the hypotheses. Our null hypothesis is mu1 minus mu2 is equal to 0, meaning that we think the means of these two groups are roughly equal to each other. So we saw this format when we looked at the receipt message and tips experiment. And generally what we'll do is we'll replace those numbers 1 and 2 with the names of the groups to make it easier to understand and keep track of what we're doing. Okay, and then there's one other thing to note here. In this class, we're always going to set our two-sample t hypotheses using a value of 0. So there are definitely more sophisticated ways of choosing and setting that value, but those are something that you would cover in a more advanced class. Okay, so our alternative is also going to be of the form mu1 minus mu2. And then we'll use either a less than, more than, or different than 0. Okay, and then lastly, as always, hypotheses have 4 parts. So you want to indicate which hypothesis you have, either the null or the alternative. You're going to have a statement about the means. So in this case, mu1 minus mu2. Then you'll have a sign equals to, less than, greater than, not equal to, and then a value. So for a two-sample t, that value is always going to be 0 in this class. All right, so let's look at an example. A microbiologist wishes to determine whether there is any difference in the time it takes to make yogurt from 2 different starters. So we have a starter that we're going to abbreviate with the letter A because I can't pronounce that word. And then one word that we're going to abbreviate with the letter B. So 2 different starters. 7 batches of yogurt were made with each of these starters, and the time in hours to make each batch was recorded. So we do have 2 separate and distinct groups. We made some yogurt with starter A. We made some yogurt with starter B. They are separate groups and separate starters. So we do have a 2-sample t. And so we're given the order of subtraction here is A minus B. So rather than mu1 minus mu2, I'm going to use mu A minus mu B. And for the null, that's going to be equal to 0. And then for the alternative, it's still mu A minus mu B. So I'm mirroring that subtraction, but I'm going to use not equal to 0 because the question that's being posed here is there any difference in the time? So there's no direction as to maybe one's faster or slower than the other, just whether they're different. So that's telling me not equals 2, which is a 2-tail. Okay, so one thing to note, I'm always going to give you the order of subtraction for these problems. You can definitely subtract it the other way, and really the only thing that changes is that it's going to flip the sign on your test statistic. So just to kind of make it easier all the way around, I'm going to give you the order of subtraction so you can easily compare your answers and get a sense of whether you have the right idea. Okay, so let's try one more together. During the first 3 months of a training program, a new cashier was timed for the number of items per minute that they rang up on 18 randomly selected occasions. In the same time period, an experienced cashier was timed for the number of items per minute that they rang up on 14 randomly selected occasions. We want to test whether an experienced cashier will be able to outpace a new cashier. All right, so one thing to note here is that there's 2 different sample sizes here. The new person is 18 data points. The experienced person has 14 data points. If you have 2 different sample sizes, automatically you have a 2-sample t. You don't even really have to think much harder than that. 2 different sample sizes is telling you a 2-sample t. So you're going to have 2 independent groups. The problem alludes to, it says, test whether an experienced cashier will be able to outpace a new one. So we are going to use new minus experienced here. So that's kind of what that translates to into our order of subtraction. So our null hypothesis here is going to be that the mean or mu of the new minus the mean of the experienced is equal to 0. So we're just mirroring that subtraction order. The alternative hypothesis might be a little trickier for some people because it's either going to be a left or a right tail. So they're telling us to see whether someone is outpacing another person. So that is telling me that someone has to be faster than the other. So I'm going to show you one way that you can kind of reason through it. There's, I'm sure, a number of ways you can do it. And whatever you do that works is fine with me. But what I'm going to do is I'm going to start by writing these 2 means in the same order the subtraction appears. But rather than using a subtraction sign, I'm going to put an inequality between the 2 of them. So I have mu of the new is less than mu of the experienced. So what I've done here is it says we're looking for the number of items per minute, and an experienced cashier is supposed to outpace the new one, meaning they should bring up more items in a minute than the new person does. So the way the inequality works, that side that's open is the side that you think is bigger. So I put that less than in there. So meaning that the new cashier is going to do less, the experienced one is going to do more. And I find that most people are able to put that inequality in there correctly when you're just putting it between the two of them. So to get from here to our actual hypothesis, I need to get both of those terms on the same side. So I'm always going to subtract the one on the right, the mean of the experience, and I'm going to subtract that from both sides. So it looks like this. And when I carry out that subtraction, what I get is that the mean of the new minus the mean of the experience is less than 0. So that's going to be my alternative hypothesis. That's a left tail hypothesis there. And then just in terms of kind of generalizing how this works, we can kind of replace this with the idea that the mean of a smaller thing minus the mean of a bigger thing is going to be less than 0, meaning we're always going to get a left tail test. Okay, and that particular format, if that's helpful to you, is on the previous page with phantoms. So that's there if that can be of some help. All right, so we have 2 more to look at. I would love for you to go ahead and pause the video and give both of these 2 a try, and then we'll take a look at them together. All right, so coffee stations and offices often just ask users to leave money in a tray to pay for their coffee, but many people cheat. Researchers at Newcastle University replaced the picture of flowers on the wall behind the coffee station with a picture of staring eyes. They wondered if the average contribution increased when people felt they were being watched, even though the eyes were not real. At the 5% significance level, is there evidence that the mean contribution increased if a picture of eyes was posted rather than a picture of flowers? So we're going to use the order of subtraction, eyes minus flowers. So our null hypothesis, the mean of the eyes minus the mean of the flowers is equal to 0. Our alternative is that the mean of the eyes minus the mean of the flowers is greater than 0. Because we thought with the eyes that people would put more money in. So the eyes should be a bigger number. So when I subtract those, I should get something positive or bigger than 0, which is a right tail test. All right, and then one more. Do people walk faster in the airport when they are departing or when they are arriving? The walking speed of travelers at Denver International Airport was measured. Is there a difference in the mean walking speed of departing versus arrival? So we're going to use the order departing minus arrivals for our subtraction. So it makes our null hypothesis the mean of the departing minus the mean of the arrival is equal to 0. And our alternative is that the mean of the departing minus the mean of the arrival is not equal to 0. Because all it asks is there a difference? So that gives us a 2-tailed test. All right, come back in the next video. We'll do a little bit more with hypotheses, but we're going to add in those conclusion statements as well.